Hi, welcome to Unit 2, Lesson 1, Activity 3, Notes. So in this activity, you're presented with 4 different moons. The first thing it asks is, what do moons A, B, and C all have in common that moon D does not? So go ahead, pause the video, and just jot down your thoughts on how D differs from A, B, and C. So hopefully you notice that D looks to be a little bit more smushed than A, B, and C. So it's definitely got some distortion happening. Moon D is distorted, more smushed. Okay. So then the second question said to use numbers to describe how moons A, B, and C are different from moon D. So what we're going to do here is we're going to take a look at some different measurements. So the first measurement I want to look at is if I were to draw a box directly around each moon, what would that be? So I would have a box here. And in doing that, I see my box is a 12 by 8. So it's 12 tall and 8 wide. For box B, I draw it again. And this time for box B, I see that it's 6 tall and 4 wide. Box C is 3 tall and 2 wide, whereas box D is 6 wide and 4 tall. So if I wanted to look a little bit closer at some of the ratios, because that's the idea of this lesson, is we're looking at those equivalent ratios. I could say that my ratios of my length to my width for A, B, and C are all equal. So for example, for rectangle A, we have 12 to 8. And if I simplify that by dividing by 4 over 4, I get 3 over 2. Okay, same thing for B. If I start with 6 over 4, simplify that by dividing by 2 over 2, I get 3 over 2. And then finally for C, I already have 3 over 2, so I don't have to simplify. Whereas D is 4 over 6, right, because we're doing our height over our width, and that simplifies to 2/3. So I can see that in this right here, my ratio of width to length is the same, whereas my ratio for D is not the same. So let's go ahead and put that into table form. So we said for C, that would be 3 to 2, and then 3 to 2 as a ratio. For B, be 6 to 4. Again, as a ratio, simplifies to 3 over 2. For A, we have 12 to 8. And that again simplifies to 3 over 2. And this is supposed to say D. D is 4 to 6. Oops. And that simplifies to 2/3. So a little bit different when we create our ratios. Another way of looking at it is instead of drawing a box around the entire rectangle, you can instead look at the widest part of each moon and compare it from one tip to the other tip. So for example, if I look at A, the widest part of the moon is right here, and that has a length of 4, and the tip we said has a length of 12. So I'm going to go over here and put that for A, so 4 to 12. And when I write my ratio, I'm going to do that as 12 over 4, and I see that simplifies to 3. So I'm going to repeat that for B, C, and D. So for B, my widest part is 2, and my tip is 6. Tip to tip is 6, so I have 2 to 6. 6 divided by 2, well, that's 3. For C, my widest part is 1. My tip to tip is 3. So 3 over 1 is equal to 3. And then finally for D, my widest part is 3, but my tip to tip is 4. So widest part 3 to 4. So when I write that, I write it as 4/3. Not the same as as 3, right? 4/3 is not equivalent. So what ends up happening here is that we can end up seeing that A, B, and C ratios are all equivalent, whereas moon D has a different ratio. And if we think back to when we talked about scaled copies, this actually kind of connects back to it, because we can also say that moon A, B, and C are scaled copies of each other because of those equivalent ratio. Okay, so make sure you have all of this filled out, and once you do, you can put your notes away, take out a pencil, and grab a cool down. Thanks for watching.